Hello everyone, let's do question number 4 from AP Precalculus 2025 Free-Response Questions. Let's read through the fourth problem. It says, unless otherwise specified, the domain of a function must be assumed to be set of all real numbers of x, for which fx is a real number. Angle measures for any trigonometric functions must be given in radians. Solutions to the equations must be real numbers, and for non-calculator papers, non-calculator questions, as you might know, question number 3 and 4 are non-calculator questions. The expressions must be obtained or simplified without a calculator. For example, if there's any log value that you can simplify without a calculator, or any trigonometric function, any inverse trigonometric functions, all of them must be evaluated without a calculator, so you always have to leave your answer in the most simplified form. Similarly, if you have algebraic expressions, you must use algebraic methods, rules, exponents, or logs to simplify your answers wherever applicable. Let's try and do the first part. The A part says, there are functions given g and h 2 log base 3x, and hx is given as 4 cos square x. We have to solve for gx is equal to 4 for values of x in the domain of g, and domain of g we will assume to be any real number. Let's see how will we solve for gx equal to 4. Now gx equal to 4 would mean 2 log base 3x is equal to 4. First and foremost, we will use the log property. Log base ab to the power m can be written as m times log ab. Now here we have something in multiplication with the log expression, so that can go to the power of the argument, which means log base 3x squared is equal to 4. Now using the fact that any log expression can be written as an exponential equation. So if I have log base ab as a value x, then a to the power x will give me b. So similarly, I'm going to use that logic here. Say x squared is 3 to the power 4. Now x squared is 3 to the power 4 would mean x squared is 81. And two values of x that you can think of are 9 and negative 9. Now, if you observe, x is the argument for log, and x cannot be negative 9. Because if 3 is the base and you raise 3 to any power, its answer will never be negative. It can never give you a negative 9 as your answer because 3 is positive. So whenever the base is positive, the argument of log is also positive. So what is the domain of g? G's domain is x being greater than 0. It cannot even be 0. So hence the value acceptable for x is x is equal to 9. Let's look at the second part similarly. Now the second part says you have to find out values of hx for value of x for which hx is equal to 3 for x lying in the interval 0 to pi by 2. Now 0 to pi by 2, as you must know, is the first quadrant. Here 0 has a closed bracket and pi by 2 has an open bracket, which means 0 is inclusive while pi by 2 is non-inclusive. So I have to look for all values of x in the first quadrant, which means from 0 to 90. Let's solve for this trigonometric equation. It's 4 cos square x is equal to 3. I can take 4 to the other side. Cos square x is 3 over 4. If I take the square root of this function, I will get cos x is equal to plus minus square root 3 over 2. Now, if you look carefully over this quadrant, in the first quadrant, values of cos x are positive. Cos x is negative in the second and the third quadrant, while cos x is positive in the first and the fourth quadrant. But since my domain is only the first quadrant, I can say cos x cannot equal to negative 3 over 2. Hence, cos x will have a value of positive 3 root 3 over 2. Now we know cos x is positive root 3 over 2 at 30 degrees. Hence x we will say, and we have to write down our answer in radians only. So x must be equal to pi by 6. So the answer for this one is x is equal to pi by 6. Let's look at the B part of the question. The B part gives me two different functions, gx and kx. The first one is a log expression, log base 2x plus 3 log base 2. And kx is a trigonometric function for 6 over tan x cos x square minus 1. Now the first part says, for the B part, you have to write down gx as a single logarithmic base 2 without negative exponents in any part of the expression, and your results, they have given you a hint, must be of the form log base 2 and the given expression. So you have to use log laws to combine gx. Let's look at how will we do that. So the expression that is given for gx is log base 2x plus 3 log base 2, 2. Now first, log base 2x cannot be simplified further, so we just keep it as it is. 3 log base 2, 2, we will use again the same rule that we used in the A part. 3 will be raised to the power 2. So this is the log rule that we're using, log base A, b to the power m is m log base AB. So here it will be log base 2 cube. Now if I know log 2 cube is 8, so I can write it 2 cube is 8. Now this will be 8 here. And then I will use another log law, which suggests that if I have log base A x plus log base A y, then they can be combined in multiplication by log A base A xy. This is the log rule we are using, the multiplication and addition rule. And then we can combine these two expressions to say log base 2 8x. So we have simplified our answer in the least form by writing it as log base 2 8x. And we have given our result in the form as they had asked to write it as base 2 and an expression in terms of x. So this is the most simplified form, and the log rules that you're using are very, very important to be remembered for these kind of questions. Let's do the second part to this. They say, can you write down kx as an expression in which tan x appears exactly once and no other trigonometric functions are involved? So this is about proving trigonometric functions to be written in a specific manner. You have 6 over tan x times cosec square x minus 1. Now if I look at the identities that I can think of for this question, is I know we have a trigonometric identity that suggests cosec square x minus cot square x is equal to 1. Rewriting this identity, I can say cosec square x minus 1 is cot square x. Now, which means I can replace cosec square x minus 1 as cot square x. Why is this useful for me? Because I have to write down an expression only in terms of tan, and you know cot and tan are reciprocals of each other. So if I replace it first, I'll get 6 tan x times cot square x. Now we use the property that cot x can be written as 1 over tan x, because my question says I have to write it only in the form of tan x appearing once. So replacing that value of cot x as 1 over 2, it can be written as 6 over tan x times 1 over tan square x. Now a tan and tan would just cancel out. I'll have 6 over 1 over tan x. Taking the reciprocal, my final expression would be just 6 tan x. So I have written down kx, which was rather a trigonometric function, only in terms of tan x here. Let's do the C part now. Reading through the C part, it says the function m is given by e to the power 2x minus e to the power x minus 12. Find all input values in the domain of m that yields an output value of 0, which means I have to solve my expression, the E expression, for mx equal to 0. Let's rewrite this expression here. It's e to the power 2x minus e to the power x minus 12 equal to 0. Now, if we read through the problem and look at it, we might not be able to solve it using any exponential or logarithmic property or any simplification using exponential and logarithmic skills that we know so far. However, this kind of expressions are special quadratics. Now you would think, where does a quadratic come in from here? I'm going to make a substitution and then tell you why does it look like a quadratic. And such form of expressions are called hidden quadratics. They're very important because they are hidden, obviously. You might not be able to see them quite clearly, but then they turn out to be a quadratic and it's very easy to solve for them. What we do in this case is we let ex as a new variable, let's say y. Substituting it, can we say that e to the power 2x will be nothing but e to the power x square? And in fact, it can be replaced as y square. So e to the power 2x can be replaced as y square, ex can be replaced as y, and this is minus 12 equal to 0. Does your expression simplify to be a quadratic? Well, yes, and you can very easily solve for a quadratic expression like this. You can factorize it using middle term splitting and write it as negative 4 plus 3y minus 12. You can factorize it as y times y minus 4 plus 3 times y minus 4 equal to 0. It splits to y minus 4, y plus 3 equal to 0. Solving for y, you get y equal to 4 and y equal to negative 3. Now, some mistakes that students make are leaving your answers here. But remember, in the expression, the question doesn't say to solve for y. In fact, the question does not even have y. You have to find out all input values in the domain of m, which means you solve for x such that they give you an output of 0, right? So we solve for x here. Replacing this, we get e to the power x is 4 or e to the power x is negative 3. Now think about it. Do you think e to the power x can give you a negative value? Remember, e is an irrational number like pi and has a value which is somewhat close to 2, right? It lies between 2 to 3. So raising a positive number like e to any power, can it ever give you a negative value? The answer is no. Hence we can say ex can never be negative 3 and ex is equal to 4. Now we have still not solved for x because my question is to solve for x. If ex is equal to 4, we can convert it to a logarithmic expression to solve for x. We put ln on both sides saying ln ex is ln 4. Using the power rule, x comes in multiplication. X ln e is ln 4. And since ln e is 0, this implies x is equal to ln 4. So I get one value for x, which is nothing but ln 4. So this is how we've solved this problem, which is very easy. It is not at all difficult. You just have to use log rules, trigonometric functions, log laws, trigonometric identities, as well as a special question on hidden quadratics. Hope you've understood all of it.